As the last part of your case study and the last part of the course, we're going to do a little bit more work with our data set. The first thing that we're going to do is test for independence between age group and gender in the data set using a chi-squared test. And the last thing that I want to introduce you to is some ANOVA testing with this data set. We haven't covered ANOVA testing, but ANOVAs are a very important way of comparing means for more than two groups. And I want to use this data set to illustrate how that might work. Let's start with testing age group versus gender to see if there's independence between the two variables or not. So we'll be using a chi-squared test for independence. We have the raw data listed here, the age groups and the genders. So what we'll do is go to Stat, Tables, Contingency with Data. Our row variable will make age group. So I'm using age group code here since it doesn't contain the extra text. And for the column variable, we'll use gender. Click Next, and then click Calculate. And here we have our chi-squared test for independence of gender versus age group. You'll use this information along with some of the other information that we'll generate and some information you'll generate on your own in order to complete some of the case study questions. Before you're ready to move on to that though, let's take a look at an ANOVA. A few weeks ago, we compared the average number of deaths for males and females, and we did that using a z-test for two samples. That works when there's two populations, but in the case of age group, we know there are three different age groups involved in this data set. So we would not be able to use a two-sample test for that because we have more than two samples. In fact, here we have three samples. And if we wanted to go further and test for the states, we have over 3 states. We have 50 states that we'd have to test for. So we would have to utilize something else. In this case, when we want to test means that are numbering more than 2, we can use something called an ANOVA. So what we'll do here to compare the number of deaths for each age group is go to Stat, ANOVA, one way. And we want to compare columns in a single, values in a single column rather, because all our deaths are listed in one column. So that's the response, the number of deaths. And the factor is going to be the different groupings that we have. So that'll be our age group. I'm using age group code again here because this one has the extraneous text that I don't need. I'll go ahead when I have these responses and factors in and click Calculate. And here I'm given a breakout by age group of all the means and standard deviations and the number of observations in each. And then I'm giving something called an ANOVA table. And what this ANOVA table is doing is providing us with a test statistic, that's the f-stat, and a p-value to determine if all the groups on average have the same number of deaths versus that one of the groups does not, or all of the groups are not the same. So in this case we have a p-value of 0.0001, actually less than that, so we would reject the null hypothesis and then conclude that there are some differences between these groups. Now go ahead and answer your case study questions for your very last case study for the course. Good luck!